Well, hello again. Last time when we left off, I told you that this particular can, this electrolytic can right here, was 90 microfarads rated at 475 volts. It can, on the side it said it had 4 20 microfarad capacitors inside the can. Well, yes and no. Okay, but I did tell you, I'll get back to that in a minute. I did tell you that they connected all of the terminals underneath together. That hooked each of these 20 microfarads underneath there for a total of actually 80 microfarads, even though the schematic calls for a 90 microfarads. 80 would have been good enough. So we're going to take a look underneath. I'll show you how they connected all of those capacitors together in parallel. But before we do, I want you to understand something. Sometimes people don't realize this, or if they did, they forget. This is not just an aluminum can that holds 4 capacitors inside. If it had 3 capacitors, it would not just be an aluminum can that had 3 capacitors, 3 electrolytics inside. What you're looking at is the capacitor itself. This is the capacitor itself. The positive plates are on the inside, and what they did was break them up. They come off each section of the positive plates. Remember, it's coiled in a coil. They would just tap off at certain points to get the microfarad capacity they needed. And this, the can, which is in this case is connected to the chassis, this is the negative plate. The positive plates are on the inside with the foil and the wax and the paper and all that crap. This is the negative plate. Keep that in mind. This is the negative plate. Now sometimes the negative plate on an electrolytic is not connected to the chassis. It's insulated from the chassis, and almost always they'll have paper covering the entire thing. It'll be a cardboard covering the entire thing, and they'll have a cardboard insulator on the bottom where it meets the chassis, because they don't want the can grounded to the chassis. It depends on the kind of circuit you have, and you have to be very careful with those. You know, I've seen real tall cans that only had the cardboard up about halfway. The rest was metal. When you see cardboard around a electrolytic can, be careful. That cardboard is not there as decoration. It's not there to keep it clean. It's not there to give you a gripping surface should you ever have to take it off. It's there to keep you from being shocked. Cardboard means danger, people. Danger, danger, okay? Take a look at your schematic. You may find that the can is not supposed to be grounded. And that's the way they do it, and they don't want you getting shocked in the process. Let's flip it over. Here's the bottom of that can, and you can see that all 4 terminals, there's a terminal underneath that wire insulation that looks just like these. 1, 2, 3, 4. All 4 have been connected with a wire. Soldered together with a wire. Just a little round setup. So that's how they got their 80 microfarads. Each one of these is actually 20 from here to the ground. The ground on the can is established by these hold down things you see right here that hold it to the chassis. You got one there, and there's another one over there, and another one here. There's actually 4 of those, and the ones in the center are isolated from these grounds, which are the outside. Remember, the ones in the center are the positive plates. The can is the negative plate. Let me show you what that looks like on paper for those of you, who are just tuning in, just getting interested in this sort of thing. Here's those 4 capacitors inside the can. What they did was they hooked all 4. If you hook capacitors in parallel, they add. They add, okay? So we've got a 20, a 20, a 20, and a 20. All 4 of those are connected together. That's what they did. They went round, 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 round. The same with the grounds. Like so. And they hook that to the chassis. That's what we now have. We have the 4 positive plates all connected together, and the 4 negative plates, or the other plates, connected to ground. Okay, so what we're going to do is we're going to do the same exact setup, because we have 20, 20, 20, and 20, and I told you they were additive. So I always kind of like to remind myself you can draw a line all the way through that kind of shows they're all additive, makes bigger plates. So 420s would work up to an 80. Now there are sites on the internet where you can go just type in capacitors in parallel, resistors in parallel, capacitors in series, resistors in series, and they'll enable you to type in various values and give a tally at the bottom to tell you what the capacitance would be with these various values, whether it's in series or parallel. Same thing with resistors. Try to find a couple of those sites and just randomly throw values in there. You'll be surprised at what you find, especially with resistors. Alright, let's go back to the can again. So what we're going to do, you'll see that there's a group of wires to include a wire from this resistor, all connected to this one terminal that's sort of like this underneath there. You can't see it. Then we have a red wire connected to that terminal. And then over here there is another 10 watt resistor like that, a ceramic resistor, also tied to this terminal over here. This is not tied to anything, I don't think. Let me look here. Let me get the light down a little lower so we can see. I don't think that is, no, that's just connected from ground to this other electrolytic over here. So everything that's connected to these terminals, they have to come off. And it makes life so much easier for us, and I'm going to show you how. Alright folks, here's what we're going to do to get this 90 microfarad setup done. We're going to take this terminal board. The first thing I'm going to do, I'm going to run a wire in and out, across, in and out. I'm going to tie all these together with a single wire. I'll probably do that in these lower holes. Once I get a wire all soldered, and it's all basically one piece, with the exception of where the nut and the screw is, we're going to go ahead and we're going to hook it right to the chassis right there, where I've already bored a hole. I hate to bore holes in the chassis, but there's just not much I can do in this case. It'll just look like another normal screw. I mean, there's rivets showing through in these chassis and screws, you know, they're everywhere. Won't look any different than any other screw. So once we get that thing mounted and all these terminals are connected together by a wire soldered together, then all we have to do is take all of these wires that are connected to the positive terminals on the original can and remove them and solder them to these terminals here. These terminals will become the positive terminals on the capacitors. They'll all be tied together with one wire. All the wires will be connected to them that come off the can. Same exact setup, except all we've done is taken all this crap here and moved it up to a terminal board there. Then, once we get that done, we'll hook in our 100 microfarad, 500 volt electrolytic capacitor, and I'll show you how to do that. This was the original 100 microfarad 450 volt capacitor I was going to put in there, but you know it needs to be 475 volts, and you don't want to really go below voltage unless you absolutely have to, and I can't see a need where you absolutely have to. Try to keep it at the rated voltage on the schematic or above. Don't go below. So this one is 25 volts below the rated requirement per the schematic, and it's awfully huge too. Look at the size of this thing. So what I did was I went ahead and ordered another one rated at 500 volts, 100 microfarads rated at 500 volts, which is, you know what, 10 microfarads above the 90, and I meet I'm above the 475 volt requirement, so it'll be perfect. And it's smaller in size. It's not quite as long, and it's not quite as fat, not as big, or not as diameter. It's a little smaller. And what we're going to do is, once we get the terminal strip up in there, and all the terminals strapped together, and all of these wires removed from the existing terminals on the can and fastened to these here, I will take this, the one that'll be in, I ordered it, it'll be in a couple of days. I'll take this and I'll point the positive end of the can, the positive end of the capacitor, up here and connect it to the terminal, one of these terminals, probably going to be this one right here, okay? The positive end will go there, the negative end will come down and connect. I've got a ground tab here I can use, and if I had to, I could just go ahead and hook on a wire and run a ground tab over here and connect it anywhere I wanted. I could hook it right into where the transformer ground is. But first, let's get the terminal on. I tell you, to make this easier, let me go ahead and strap these together with a wire. Let me go ahead and get the terminal board up. Let me get all the wires soldered to it. I'm going to try to leave enough room in this hole right here for the lead on the capacitor. I don't want to get everything soldered up and then say, hey man, I got no place to put it. And I don't want to really wrap it around and around the outside. That would be kind of tacky. I mean, not that I haven't done it, but I prefer not to. So let's get that done and then I'll come back. Well, there we go. I've gone ahead and this wire here, I just took a piece of solid hookup wire, stripped the insulation off, came up through the top, across, down through there, underneath, up through here, across, down through there, soldered it on the top surface, and then nipped them off at each end nice and flush and clean. Cleaned them with alcohol and an acid brush. They look great, good to go. There's no need to worry about this thing being super duper tight. I tighten it up as much as I can. We're not using it for anything. It's just a mounting bracket is all it is. Now what I'm going to do, I've already nipped off one wire here. This one here. Took my brand new Chinese American cutters and I just nipped it down. There's no need to try to unsolder all that mess. If you try to unsolder those wires, they're stranded wires. I believe they're stranded. They'll be splayed everywhere. There'll be solder everywhere. Just nip them off nice and flush and clean. Later on, if you want to take all those wires out, that's fine. But right now, I want to get them all hooked to here. But I'm going to try to leave this terminal right here open as much as I can, because when that smaller electrolytic capacitor comes in, I'm going to be hooking the positive lead to it like so. Okay, we'll solder that in, and then the negative over here, we'll find a ground somewhere. So I'll tell you what we'll do. Why don't we just go ahead and get everything taken off that old capacitor and get it up on this terminal strip. We're partway through getting the wires off of here. I've got this one off. I've got to tin it yet. And I've got this one off. I've got to strip back all three of them here. The third one's right here. I've got these three stripped back. Now let's go back down to the capacitor. You'll remember I told you that all of the terminals were connected together with a wire, and you can see the wire running around. But there's something I wanted you to see. Once I got those wires there, they were all soldered to the same place, and I still have this resistor right here. It has a lead coming down, this big old ceramic capacitor resistor coming down. I still got to get that thing off. I'm not going to snip that off. I'm going to try to melt the solder and get that thing out from under there. I don't have a whole lot of lead to play with, but there's something I wanted you to see. All of these are supposed to be soldered together to form the 80 microfarads. I want you to look at this one right here. Look at this wire right here. If I can get it down in there. I want you to watch this lead over here. That one right there. Look at that. Wasn't even soldered. Just run through the hole. Everything else was run through the hole. A big glob of solder was put on there, and this one right here never got the solder. Oh. Always be on the lookout for that stuff. When you have a ton of wires soldered to a terminal, there's a good chance one of them didn't get soldered. And I was looking for that when I started nipping off these wires, these excess wires, after I got the insulation off the stubs that were left. I was looking for just that, and I said, holy mackerel, there it was. That's where experience comes in. I've seen that so many times, so many. One more thing, I got the lead from this ceramic resistor out here. Look how crooked that thing is. This is where a lot of folks run into problems. They don't know how to straighten them right, and they wind up breaking them off close to the body of the resistor. You know, it's no big deal. You can always get another one, but you know, this is why it pays to have a pair of duckbill pliers, once again, that have no teeth in them. You just take it like that where the kink is. I'll do this top kink right here, or top bend. You just get it right in the center between the teeth and just squeeze it. And it straightens right out. See how she straightens out? Do the next one. Now they're not going to be exactly 100% straight, but you know, you don't have to wiggle it back and forth to try to get it straight. All you got to do is squeeze. Starting to straighten out already. Now get down here with this one. You cannot beat a pair of good duckbills. Alright, this is going to take two hands to do this one. That's about as straight as I need to get it. I'll have to bend it again in order to get it over here into one of these holes on this terminal board. But I'll tell you what, that's a 3,000 ohm 10 watt resistor. Why don't we just go ahead and check out the resistance of it while we got it out. If it could be bad, I may have to just go ahead and get another one after all that bending and straightening anyway. Okay, I've got a lead on each end of it. It's out of the circuit. Let's take it down. We'll move it down here to the, it's supposed to be 3,000. We'll have to go to the 20K to read 3,000. Well, how's that for close? That's very good. I'll go ahead and solder that baby up just the way it is. Well, there we go, ladies and gentlemen. All the wires have been stripped off the old capacitor positive terminals, and they're all soldered up here now to each of these lugs. I actually managed to keep this one open for our 100 microfarad capacitor. That worked out real well. Now, I know this doesn't meet the standards of Phil over in England there. Steel City 321 PV. He went to a school that taught him how to do this. He would have designed an entirely new circuit board and wound up redesigning all of this to make way for the circuit board, and then redesigning all of this to make way for that, and then redesigning all of this. You know, this is the way an American does it, Phil. It works great. Oh, it's nice to have the kind of skills Phil has. Unfortunately, I do not. Anyway, this one right here, this 10-watt resistor, both the one end of this 10-watt resistor and this one over here were both connected to the positive lugs on the capacitor, so they both had to go up here. Unfortunately, this lead was really too small. You can see the distance. I had to splice a wire on to have it make, and then of course I went ahead and put a lot of heat shrink on that thing. I don't want that heat shrink getting anywhere near that ground wire right there. I'll probably take that ground wire and pull it over this way as far as I can to get it away from this wire. Hoop! There's the whistle for the break time. It's coffee waiting for me. I'll be back shortly. The new 500 volt 100 microfarad electrolytic came in a day or two earlier than I thought. So I went ahead and installed it. You know, the positive end up here, the negative end I hooked down here to this grounding tab here and just soldered it up. Worked like a charm. Now you can see the difference between this one and this stick of dynamite that I initially was going to put in there. Not going to happen. That is way big. I'm glad I went out. So I probably even could have got one smaller than this out on the internet, but I didn't feel like messing around too long with it. I came along across this one. I said, that's it. It's a lot smaller than what we had. They had the diameter. Fortunately, you know, being a good eBay seller, they gave us the length of this thing and the diameter, which really helped, because then I knew for sure it was smaller than that big one we were going to use. So where are we at now? Well, we're ready to move on to the next and last electrolytic capacitor. You know, I'm really glad that I did this, because that wire that was not soldered to that terminal would have given us some hum problems, and it would have been a pain trying to figure out what was wrong. You couldn't even see it. One more time, I want to go over that. Anytime you come to a terminal, it's got a ton of wires soldered to it. Even if it was done at the factory, it doesn't matter. If it's got 4, 5, 6 wires all soldered to the same terminal, look at them very carefully. Chances are good that one of them did not get the solder it was supposed to get, and it's loose. Never been soldered. It looks like it is, but it won't be. Examine closely. Tug on them with a pair of tweezers. Get your nose down in there. Dig around. That's what you're supposed to be doing anyway. We're hobbyists. We're supposed to be doing that sort of thing. All right. The next, let me zoom in here. Our next electrolytic is just going to be, now this is one of the this is the 47 microfarad that someone put in there a while back, and they connected it all together. It's nice and secure. Not exactly the way I would have done it. This is a ground wire here. It has nothing to do with it. It's not exactly the way I would have done it, but it's good. You know, it's in a good position. It's out of the way. And originally I told you this last, the whole setup on this thing would be a 40, a 30, and a 20. Well, what they've done here is they've gone, a previous repairman put in a 47 for the 40, and then a 30 and a 20. They just went with two 20s. I mean, two 40s. They connected, once again, you can see where they connected two of the 20s together, this one with that one, and this one with that one, and they just made them all essentially 40 microfarads. So, you know, with the required voltage, I think is what, 450 volts for these. So what have we got to take loose here? Well, let me see. We got a red wire on this one, this red wire right here, and we've got to take the bottom of this resistor off here. This is 1.8. I'll have to check the schematic and see what it says. But let's do this one first. We'll go ahead and put up another terminal strip up here. We'll connect this end of the resistor, if I can get it out of there without breaking it. Boy, those are some thick leads there. We'll just connect this and this to the one of the terminals up here that'll get the positive end of the next capacitor. Then once I think, I'm just kind of hoping I can bend it all around and make it fit. If not, I'll have to dig out another resistor and we'll have to do it differently. Now what about the next 20 microfarad lead? What are we going to have to do there? Well, we've got, what do we have here? Let me see. We've got a resistor here. This big resistor lead is connected to it. These two red leads are connected to it. And it would seem to me that there was one other thing. Let me look. Nope, it's just the resistor and those two red wires. So hopefully we'll have enough slack in the wires to pull them over and connect them to the terminal once I get the terminal board put up here. So let's do I don't know, maybe we ought to do the one closest to the chassis first. That'll give us more room. Maybe not. I'll figure it out. No big deal, okay? The 18,000 ohm lead, resistor lead, has been removed from the terminal down there, and so has the red wire. And we're going to take this terminal strip this time, a little bit different. And this, I've gone over this once before. I showed you the difference between this type of terminal strip right there and this type of terminal strip over here. We'll go over it one more time real quick like. This is an isolated terminal strip. These terminals are separate from the ground attachment. Okay, so they're isolated from ground. This one here is a non-isolated terminal strip, in that, you know, one of the terminals does in fact connect to ground, but of course the rest of these will never go to that ground unless you connect them. But this is called a non-isolated strip because there is a grounding tab on it where you connect it, grounding terminal, and this one does not. This is isolated. Alright, that's it. Moving on now. Let's go ahead and test this resistor. It's supposed to be 18K. Let's find out. I don't want to solder it up and find out it's not 18K. Let me see. We'll go down here again to the, for those of you who are just picking up on this. Believe it or not, I've had people contact me and say, how do you know what scale to set your multimeter up on when you're doing either a voltage or resistance check? You know, it's just whatever number it fits in. I'm doing an 18. Now I could set this to 20. I could set it to any one of them, 20 or above. But you go to the lowest one. 18 will nicely fit within the 20 scale. We're looking for 18. I can't get much closer than that again. Man, we're really looking out here. Let's get the terminal on and get that red wire and the resistor soldered up. We are almost done. We're almost done with this chassis, and we're almost done with this video. And I know some of you are saying, yeah, I'm glad to hear that. All right, I've got everything removed from this second electrolytic can. I've got the two wires already soldered up to the terminal strip that I mounted. And I'm getting ready to ohm out this 2700, looks like a 1 watt resistor. If it's within 20%, we're good to go. So let's find out. I said it was 2700. We'll go down to the, again, we're going to go down to the 20K, the 20,000. Looking for 2700. Man, there's a glare on there, huh? Yep, we're good to go. It's within, it's just slightly over 10% over. So we're good to go on that. So what I'm going to do now is just solder this up. in order not to put a strain on this resistor, let me get a focus here, let you understand what I'm doing. You don't want to be straining your resistors too much. This one's already going to be at a pretty good strain. So I'm going to go ahead and hook it here. Then I'm going to run a jumper between back here, and then, but I'm not going to solder the jumper in. I'm going to wait until I do my get my 40 microfarad electrolytic up through the hole, and then we'll go ahead and solder it. But I want to tie these two together so when I hook the electrolytic, it'll all be one thing. So we're going to have an electrolytic here and electrolytic here, and that'll be the positive side. The negative grounds, hopefully I can tie them together and bring them back and connect them to right here, which is connected to the chassis. That's the plan. I can just insulate it, bring it on around, solder it right there, or bring it back up through the holes here. I'm not sure which. I'll worry about that when the time comes, and we will be through. So let me finish up with this baby here and get the cans in place, or the electrolytic cans. That's it, everybody. I tied these two together right here with a jumper wire, and then soldered the incidentally on the schematic, it's a 40 and 2 30s. That's what it was. They actually had the wrong sizes connected inside this chassis. It's the right size now. I used 33s instead of 30s. Anyway, we're jumpered together. We got 130 connected to it, and the resistor and the two wires are all one piece now. Same over here. One red wire coming in from the bottom, one resistor, and all one piece now connected to this second 33 microfarad electrolytic capacitor. And then of course the ground, I just tied the two together, put some heat shrink on it, and then I did a tie down here where to this bundle where to kind of keep them stable where they wouldn't move around. Then I just ran a ground wire up here and soldered it right to here. That's connected to the nut bolt that gives us our ground. Well, that's it. I'll tell you what, this has been a long haul, huh? We'll go ahead and call this chassis restored for now. I mean, you know, you never know until you fire it up. All I have to do now is I'm going to put some, move this light here a little bit. I'll put a little bit of clear coat on the outside here where those screw heads are to keep it from rusting. And I'll put these knobs back. I have 3 knobs to put back on the other side. I gave them a good cleaning. And that's it. We'll stick this away and cover it up, keep it from rusting, hopefully. Alright, what's next? The torque mat is next. This is it right here. It's called, the actual name is the torque mat selector unit. The TSU1 code A. Well, you know as much about it as I do now. If you've never seen one before. This got some problems, you know, underneath. Doesn't have half the electronics though that this one did. But all of this will have to be cleaned. We're going to have to take this off. I think this is called the pulse amplifier, pulse something or other. Let me see, it might say on the side. It's a pulse something or other. There's a 12AX7 that sits in here, a tube. We'll have to remove the top, look underneath. Supposedly some stuff under there burns up fairly easily, and of course it's all enclosed. I can see why. But we'll go ahead and take a look at this one a lot closer next time. But I said I would get the torque mat on the bench, and I have done so. Well, did we learn something today? Or did I just bore you to death? Until next time, this is John.